This is our projected dew points. So we see moisture surging across Texas into Oklahoma, dew points in the 60s and 70s. We see those 60s not as far north on our Wednesday, and that's why we think there might be a little bit lesser of a threat, because we're not going to have that rich, moist air environment. And here we see our 925 millibar height. And so we want to watch this. Right now, these winds at 925 millibars are generally out of the south. As we go up to the 700 millibar level, those winds are slightly turning to the southwest a little bit. As we look now at the 500 millibar level, we see that these winds are almost west-southwest. And we're going to take one more snapshot. We're going to take it all the way up to the jet stream level at 300 millibars, and we almost get a due west wind. And the reason I point this out is with these particular thunderstorms, and this is all at Tuesday, 1 o'clock, we are going to have winds that are going to be changing directions with height. That is going to be one of the factors that we will look for when we are assessing the threat of tornadic thunderstorms. We see that here from the surface up to the jet stream level, those winds have rotated about 90 degrees. So there's definitely going to be rotation in the atmosphere. Another system we watch is the 850 millibar height. And so when we start to see these winds, we start to look for these red. That indicates the presence of a lower level jet. And so when we look at the 850 millibar map, we are going to start looking for these red. The reds would indicate winds in excess of 50 knots, the presence of a lower level jet. And where the lower level jet lines up along the dry line, that also can enhance rotation and moisture return into the system. And we also see the red expanding, which is a signal that this lower level jet is going to get stronger during the day Tuesday into our Wednesday. And that stronger lower level jet is going to provide the ability for these storms to be long-lived. Here we're going to look at a skew-T analysis, and this is taken from an area near Tyler, Texas, around 10 a.m. on Tuesday morning. We see temperatures at the surface with this red line about 670 degrees. The dew points very high in the upper 60s at 67. We see a deeply saturated layer up to about 800 millibars or so. There's a little bit of a dry intrusion up above 800 millibars, but nothing too significant as it's deeply saturated all the way up to the 250 millibar level. We look over here to the right and we see this LCL. This LCL is the lifted condensation level. It tells us when an air parcel is lifted from the surface, at what level does it become saturated? Where do the clouds begin to form? And we see this very low. We see it about a half of a kilometer, or about 1,500 to 2,000 feet above the surface. And that's another ingredient that helps in the development of tornadic thunderstorms, because the lower the clouds are, smaller the distance that rotation has to make its way down to the surface in developing a tornado. We're also going to look here at these CAPE values. They're generally around 1,000. The mixed layer CAPE at 853, the most unstable at 928. That's pretty juicy air. The convective inhibition, -9. It's not going to take a lot for these storms to start firing. And so then we start to come over here in the second section, and we look at the SRH, or the storm relative helicity. And when we look at these storm relative helicity, we are looking for things like values over 200. When we see the storm relative helicities over 200, then that's an indication that there is enough rotation in the storm. So these storm relative helicity values, high as they are another indicator that rotation and rotating storms are possible if these line of storms remain as discrete supercells. If they form into a long congealed line or a mesoconvective system, that's going to weaken the tornado threat, but it's going to increase the severe weather threat of strong winds and damaging hail. There is a lot of shear with this particular system. And so when we see moderate shear values 40s, 50s, even approaching 60, that is an indication strong winds, hail is likely. As we start approaching the surface, the 6 kilometer shear at 72, that's strong shear. That's why we think supercells, tornadoes, and organized, long-lived storms are possible on our Tuesday. We look over here at the hodograph. We see that it rotates with height. We saw that on the surface and the wind maps as well. So it kind of makes a curlicue and keeps rotating. All indications that tornadic thunderstorms are likely.